All right. Hello, everyone. Today I'm going to be talking about continuous and automated performance benchmarking for your database. So I'm Florent Poinsard. Fun fact, I have the same shirt today. I'm a software engineer at PlanetScale. I'm also a maintainer of Vitess, and I've been working with my school for a little bit over 2 years now. I just graduated, and outside of computer science and writing code, I just love snowboarding, traveling, and taking pictures. So today, we're going to have a small agenda. We're going to begin with what is performance testing, try to explain what it is, what it entails, and why it matters. Then I'm going to move on with different benchmarking tools for databases. And then I'll move on to an introduction to Arewefastyet, which is the main topic of today's talk. And then I'll dive a little bit deeper into what is Arewefastyet, and then we'll finish with short conclusion, question answers, and some resources for you to learn more or just discover more. But before we begin, I've opened a pull request. I've made a small change. I've discovered a new goaling function, which is time.sleep. I'm not exactly sure what it does, but I just want to get my pull request merged. I have a change. I'm proud of it. I want to see it into the code base. But before I do that, I want to actually make sure that it's not introducing any performance regression. So I'm going to add a label to my pull request, which is benchmark me. And we'll come back to that same pull request in a moment, and we'll see what the results are. So what is performance testing? I think it's important to draw the distinction between functional and performance testing, which are totally different. So functional is going to be, unit test, end-to-end test. You probably do this a lot. If there is a lack of functional testing, it's usually going to be highly visible to the end users. Like, let's imagine you have a feature, but your feature doesn't work anymore. Then your users are really not going to be happy. Functional testing is usually pretty easy to perform. There's a lot of tools to do it and a lot of methods I can think about, like CI/CD, methods like TDD, like test-driven development. There's a lot of culture around it. On the other hand, performance testing, well, there's a little bit less culture around it. If you have a lack of performance testing, it's usually going to be less visible to your end user. Like if your website performs maybe 1% less better than before, your end user is probably not going to see it. However, you as a maintainer, as an administrator, engineer, you're going to see it in the long term, because just 1% increase in, for example, response time usually means 1% more compute cost. Performance testing is also usually harder to perform. It requires more complex tools, longer pipeline, and generally speaking, there's less tools and culture around it. Here are 4 types of performance testing that I could think about. So first one is load testing. So this is the process of testing your software or your application under a normal load. So you want to make sure that, you build a website and you want to make sure that it supports the expected load. Then we have stress testing, which is a little bit different than load testing. You want to make sure that it supports like a very high peak of request, for example, so like an unexpected load. We also have endurance testing. So this is when you have an application and you're going to do like a 1 day or maybe a few weeks long test to make sure that there's no performance regression over time, there's no memory leak, there's nothing degrading with time. And then finally, we have scalability testing. So you're going to make sure that your software or application is able to perform at the same speed and level, even though you scale up, down, horizontally, or vertically. So performance testing matters. Maybe you don't agree, maybe you do agree, but if you don't agree, I'm going to try to make you agree with this. So what happens if you don't have performance testing? One thing is, okay, let's imagine you have a website. If your team didn't do any performance testing, I think you can expect lower responsiveness, which will lead to lower user experience. And that will lead to also higher resource cost, like higher compute cost, like I mentioned before. And another issue with lack of performance testing is, imagine, so you develop your website, your application, and then you release a new version, you're proud of it, right? And then maybe 2 or 3 months later, you realized, oh no, there is a performance regression, which is pretty bad. So you have to go back to your code, which is like maybe 2 or 3 months old. You have to find where that performance regression was introduced. You have to bisect all your commits. You have to find a fix, and then you finally have to publish it. On the other hand, if you did have performance testing, you will have detected that performance regression early on in your development cycle, and you wouldn't have to go back to your code 2 or 3 months later, switch context, etc. So all of that leads to shorter development cycle. And just the opposite of no performance testing, it leads to lower resource cost and higher responsiveness and better user experience. So if you still don't agree on the statement that I made before that performance testing matters, I have 4 numbers for you. First one is, coming from a study that Capgemini did in 2018, so it says that 62% of users are less likely to use an application again if they experience performance issues. And that's the thing, right? Like if you build an application, you invest money and time into it, you usually want your users to come back to your website or your application. From the same study that Capgemini did, they say that 49% of the users will expect their web page to load under 2 seconds. So 2 seconds might seem like a big number, right? Like you rarely see any web page load under 2 seconds, but just imagine you accumulate all the performance regression over and over and over without ever catching them. That might happen. That's another study, a second study from App Dynamics, which they've contacted a bunch of organizations, and out of all those organizations, 98% of them recognized that performance testing was important, but only 34% of them had formal performance testing. And when they did have performance testing, another study shows that 19%, there's a 19% performance improvement when a company invests in performance testing. So, okay, Percona Live is a conference about databases, right? So what is important in databases? I think we all know that a database will play a very important part in your application. So again, let's assume you have a website, you get a request to your website, that will usually entails a bunch of different database query, maybe like a query for your user information, a query for the shopping cart of that user, and all the items that the user can possibly buy. Anyway, so if your database is performing badly, then all of the website, like all of the request chain is going to be affected. And let me share you a small story that happened in Vitess version 6. So that was like, I think 3-4 years ago. That was a long time ago. But basically what happened is that someone, like a team, made a change to the code base. And we did V6, when we did the release of V6, and then later on we realized that we had a performance regression after a few end users complained to us. And then the whole team had to go back to the code, they had to dig into what happened, etc. And then finally found the issue. So basically the issue is that for each query that you will send to Vitess at that time, we will do like an extra topological for no reason, basically. So anyway, we had to go back to the code and we had to do several patch releases. We have to make sure that all the end users were using that new patch release. That wasn't good. And you know how we could have avoided this? By using benchmarking tools for databases, which leads us to our next topic. So I've come up with a few tools for benchmarking databases. There are a lot more tools, obviously, but we have, for example, Apache GMeter, which it used to be like a functional testing tool, but now it evolved to be also a benchmarking tool for databases. It's manual, you have to install it, and then you can manually run your benchmark. We also have HammerDB. That's actually a great tool. You can benchmark your SQL databases with it. You have a bunch of workloads that you can use, but again, manual. We have Sysbench. I think maybe probably a lot of people here know Sysbench. It used to be like a system benchmarking tool, but then it evolved to also be like a SQL benchmarking tool. But again, manual. So I think in all the research, I think it was very hard to find a tool for SQL which was continuous and automated. So that's how we came up with Arewefastyet. What is Arewefastyet? So Arewefastyet is basically a continuous and automated benchmarking tool. It is focused on Vitess, which I will come back to in a moment. So it benchmarks SQL, like it's fully using SQL. It is an open source project and it runs benchmark daily and on demand whenever there is a new release or whenever we have a pull request which is labeled with benchmark me. Whenever a benchmark is done and then it detects performance regression, it will report them on the website and also on Slack. So let me just say a few words about Vitess before we move on the talk. So it's a scalable distributed cloud native database. It is part of the CNCF. I think it joined in 2018, graduated in 2019. It started at YouTube, I think in 2010 as a scaling solution for MySQL. And it is massively scalable, highly available. That's because we have that concept of primary replicas. We can fail over whenever a primary is no longer working. We have that concept of sharding, so you can shard and horizontally scale your database as much as possible, as much as you want. And it is used by many companies in production. Just 3 words which will help us for the rest of the talk. So in Vitess, we have that concept of VT-Gate, which is basically a proxy layer in front of all your MySQL instances. And then we have VT-Tablet, which is a sidecar of all your MySQL. Like each MySQL instance will have a VT-Tablet attached to it. And then the VT-Tablet and the VT-Tablet and the VT-Gate will communicate between themselves to send the queries, send all the instructions, etc. And then we have a shard. So a shard is basically a subset of your logical database. All right, back to Arewefastyet. So how did we come up with Arewefastyet? So when I joined, when I started working at Vitess and when I joined PlanetScale, both at the same time, we didn't have any performance testing tool, and we still had that memory from Vitess v6, basically, of finding a performance regression later on and then having to do the extra work of finding the cause and then fixing it. So we decided to come up with a tool to detect performance regression. And like I said, we wanted to detect performance regression. That was the main goal. We wanted the tool to be self-driven. Like we didn't want any engineer or anyone in the team to have to manually do anything on the tool. We wanted to be able to compare performance across different versions of the code base. So like you will be able to compare the main branch with, for example, version X. And then even before release, you will be able to say, okay, it's actually the same performance. We're green to release. We can go ahead. We also wanted the benchmarks to be as reproducible as possible. So that is because we wanted to be able to easily debug a benchmark or easily dig into why a benchmark was saying that it's not performing well. And to be able to, so if you do a benchmark on main, then we wanted to be able to do the exact same benchmark on a different SHA, basically on a different commit. And the tool should be configurable, like everything should be written down in a file, everything should be configurable, and that's it. And we also wanted to benchmark the database on the macro and micro level, which I will come back to later. So once we had all of those goals, we had a plan. But how do we actually make that plan work? So here's the methodology of Arewefastyet. So for each benchmark, we use the exact same configuration, only the SHA will change, like the commit. We measure the exact same metrics at the same time, the same way. We have 6 different workloads, meaning that if you want to benchmark the main branch, we're going to execute 6 different individual workloads on that same commit SHA, and then that will give you the full results of your benchmark, basically. And for all the benchmark, we have the exact same environment, exactly the same machine, so it's not asynchronous, everything is sequential on the same machine. and we use bare metal servers for everything. So we opted for bare metal servers because it was the most stable option compared to, for example, cloud solutions. So here's the simplified overview of the architecture of Arewefastyet. So we have 4 main components. I'll begin with the front-end backend server, which we can divide in 2. So we have the website, which will serve the UI, which on it you can compare the different versions of Vitess. You can see all the benchmarks being in the queue or who have been executed in the past. And then on the same component, we have the execution manager. So that component is very important as it will automatically trigger and start new benchmark and create new execution pipeline. And the execution pipeline is basically the entire benchmark. So whenever you want to do a benchmark, for example, on the main branch, you're going to create an execution pipeline given a configuration file, and the execution pipeline will do everything for you. And whenever we do a benchmark on that execution pipeline, all the results are being written in the metrics collector, which is basically a time series database, and also on the backend SQL database. We use PlanetScale for that one. So how is it continuous and automated? It is continuous because basically that front-end, back-end server is the one triggering benchmark continuously. You don't have to do anything to trigger a benchmark, except if you want to manually benchmark a pull request. So we have 3 different triggers. First one is we trigger a benchmark every night at midnight on the main branch and on all the release branches that we have in the code base. If there is a change, like if, for example, on the weekend, we usually don't have any benchmark because we don't have any change on those branch. So that's about 4 branches because we have main and then we maintain 3 release branches. And then we have a second trigger, which is as soon as there is a new Git tag in the repo, benchmark will be triggered. And like I said before, as soon as we have a PR labeled with benchmark me. And it is automated mostly thanks to the execution pipeline. Like I mentioned before, you just give it a configuration file, which is already pushed into the Arewefastyet code base. And that will handle the entire benchmark for you. So you don't even have to do anything. You just feed in the configuration file, which the front-end backend server does for you, and then that will handle the entire benchmark. It will compare the results, it will publish the results, it will do everything. All right, so let's dive a little bit deeper into Arewefastyet. I've talked a lot about the execution pipeline, but here is how it looks on the inside. There's 6 main steps. First one is, like I said, we feed in a configuration file, and then we're gonna set up the infrastructure. So we have that execution server at the bottom, which is the bare metal server. And when we say set up the infrastructure, we basically make sure that the entire server is clean. There is no more process, like weird stuff running on it, etc. Everything is ready to host a new benchmark. And then we install everything that we need, all the packages. We install Vitess. We set up a Vitess cluster so we can send queries to it. We install basically everything that we need. Third step is to actually start the benchmark. And that graph is actually showing wrong, but basically steps 2 and 3 are being done with Ansible. So yeah, we start the benchmark. The benchmark will begin. It will run. It's either going to be a macro or micro benchmark. And during that time, we store all the results in either the SQL database, which is PlanetScale, or the metrics collector. Eventually, once the benchmark is done, we make sure to clean up the entire execution server again. And finally, we publish the results on the website and on Slack if ever there is a regression. Yeah, go ahead.
I'm assuming the execution server is kind of smaller than like a production environment. So if so, how do you trust the benchmarks at scale?
So I think that it's more about making sure that in the same configuration, like exactly the same configuration, it doesn't perform less better, basically. So like, if we know that it doesn't perform less better, we can assume that even at scale, it wouldn't change much, basically. So I will come to the setup of, the configuration of the execution server in a moment. Does that answer your question? Or okay. So here's the sample configuration file. Pretty simple, but basically we have the type of benchmark that we want to execute. Here it's OLTP. We have the schema that we want to use. We have basically all the configuration. We have the time that we want to spend, the number of tables, the size of those tables, and all of that stays static. Like we don't change it. It's pushed in the repo, but we basically never change it. And then we have also different steps. So under the hood, Arewefastyet is going to use sysbench to actually run the benchmark and fill in the workload. And so we have three different steps within the benchmark, which are the preparation. So you're just going to create a table, insert all the data into those tables. And then we have the warm up. So we would just want to make sure that the system is actually warmed up and we don't do the benchmark on something which is brand new and very cold. And then we actually run the benchmark. So that's where we start measuring all the metrics and results. So yeah, I talked about the workloads. So we have 6 of them. We have micro and macro. Micro is basically we execute everything, like all the Golang benchmarking function that we have in the Vitess code base, because Vitess is written in Golang. So we have in the testing library of Golang, you have all the test function, and then you also have benchmarking function that you can write. So we just execute all of that, and then we aggregate all the results. And then the macro, we have 5 different types. OLTP, which is basically the same as a normal like transactional website. We have OLTP read-only, so we don't insert anything within the benchmark. And then OLTP set, which is going to use reserved connections. OLAP read-only, same thing as OLTP read-only. However, it's using streaming instead of non-streaming request. And then we have TPC-C. TPC-C is a famous benchmark of the TPC family. So we use those 6 benchmarks, and like I said before, we get a commit, we execute all of those into the commit, and we get the results. So why did we decide to mix macro and micro? The reason behind this is if you ever find a performance regression with a macro benchmark, you're not necessarily going to know where that performance regression is coming from in your code base. So you're just going to know that your code base and your database is performing less better than before, like maybe 5% less better, but you don't know which part is performing less better. So you see a performance regression in your macro results, then you're going to look at the micro results and look at function by function which one is performing less better than before, and you'll be able to pinpoint directly where the performance regression is coming from. Maybe I should have mentioned that before, but here's the distinction between micro and macro. So micro is comparable to a unit test. You're just gonna benchmark a single function. It's very cheap, very quick to execute. And then the macro benchmark is comparable to an end-to-end test. So you're gonna benchmark the entire code base, the entire database, or maybe a bunch of features. In the case of Arewefastyet, we just benchmark the entire code base. It's expensive, and it's slow because you have to set up the infrastructure, you have to bring up the cluster, it takes a long time, etc. So what kind of metrics do we measure for both micro and macro benchmarks? So let's start with micro. So we just use the normal Golang library benchmarking results, which are number of iteration, the time spent on those iteration, allocated byte for those iteration, number of allocation per iteration, and then the megabyte per second. And for macro benchmarks, we use we measure query per second, transactions per second, latency, errors, and then the total CPU time that was used for both VTGate and VTtablet, and also the total allocated bytes for those 2 components. And here's how we configure a macro benchmark. So we have 2 shards, so we want to make sure that it's a sharded cluster so we can test as many queries as possible. Everything is on the same host, so everything is on the same execution server, and everything is local. So it's a sharded cluster, but everything is local, basically. And the approximate duration is about 25 minutes. And yeah, here are the specs for the execution server. It never changes. It's very big. It's perfect for us. It has a lot of memory. It has like 48 cores. And yeah. So let's do a conclusion. So here are the the beginning statistics of Arewefastyet when it first started. So back then we had three workloads, but we would perform between 5 and 8, 7 benchmarks a day. So it was used heavily, then it just kept on growing along the years. We have a few limitations, so obviously it's made only for Vitess, and the result variation is going to be more or less 1%. We're working on reducing that number as much as possible. And we also have, well, the UX is not very good. I'm not a front-end developer, so I tried my best, but it's not that good. So there is still some benefits. It's totally self-driven. You just have to deploy the tool, and then you don't even have to touch it anymore. You just go to the website, and then you look at the results. So that makes it more like a service than a tool, basically. And, well, it is continuous and automated. That was the title of the presentation. Future work. We want to improve, like I said, we want to improve reliability and decrease variation. That's the most important item for us. And we're also working on changing an entire front-end UI. We've hired an intern to work on that, which began in June 1st. Pretty excited about it. Do you remember that pull request that I mentioned earlier? So I got a Slack notification from Arewefastyet. It's showing me something about that pull request. Let's look at the results. So I'll just click on the link, and then I'll just wait for it to load, and then let's look at the results. Oh no, okay. So we can actually see that it improved by minus 99%, okay. All right, so that's not really good. I think that time.sleep function is maybe not the best option, but what can we see here? So OLTP went from 25,000 QPS to 40 QPS, which is not good. Same thing for all the other workloads. The read-only, the OLAP workload didn't change because I did a change in the non-streaming method. But yeah, everything is bad. All right, maybe I shouldn't merge that pull request. All right. Some resources for you guys. Here are the Arewefastyet website. You can see the results. You can compare different versions of Vitess. You can find us on GitHub. And if ever you want to reach out to us, there's the Vitess Slack. That's the best place to talk to me or the team. Thank you.